Okay. We've got the sine function are the notes for 10B, and I'm recording these so that I can post this on my YouTube channel, so you guys can go back and look at this. These are the same notes that you guys will be given in class on the sine function. Plus, this should be mostly a review since you guys have done this last year in trigonometry. So we'll still have a little stop box then. And hopefully you guys got that down. We're talking about the sine function. Now, excuse me, from the unit circle, if we talk about the sine function, y equals sine of x, we've got this little t-chart here of our x coordinates and our y coordinates. So if you actually look at your unit circle and go to 0, you'll see the sine is 0. If you go to pi over 2, and remember that pi over 2 is also 45 degrees, you will see the sine is 1, or not 45 degrees, I'm sorry, that's 90 degrees. You will see the sine is 1 at pi, which we know is 180 degrees. You'll see the sine is 0, and at 270 degrees, or 3 pi over 2, you see the sine is -1, and then back at 2 pi or back at 360, sine is 0. And so we create this cyclical pattern, and we can also get these values from a graph. So once again, you can see at the 90 degrees, sure enough, 180 degrees is 0, 270 is -1, and 360 is back at 0. Now, most of the time we are going to be working in radians, so I know I've given the degrees just to kind of get your connection between degrees and radians, but we will be mostly working in radians. So the period, the time it takes for our function to make one complete cycle is 2 pi. So that's 2 pi for our period for our basic sine function, just y equals sine x. The maximum is 1 and the minimum is -1. So I'm hoping you guys can see that as well from our graph as well as from our charts. And the principal axis, that line that's right down the middle that we talked about, is at 0. So this is true for that basic sine function. So where we go from here is we can take that basic function and perform some of those transformations that we learned in chapter 5. So this is all really important that you guys have all of this stuff in your notes, the way that function goes up and down and back to 0, and the period, the principal axis, the maximum, minimum. So make sure you guys have that. And so, like I said, remember the vertical and horizontal stretches? We're going to focus on those today, and then tomorrow we'll talk about the translations, like shifting up and down and shifting left and right. So for today, it's just the stretches. So we're going to split them up into the vertical and the horizontal and look at them on the function and on our graph. So when you multiply a letter out front, remember, multiplying again indicates the stretch, and remember when it's outside of the function, it affects the y coordinate, so that's again back from chapter 5. So it's a vertical stretch. So when we're multiplying in front, it's going to stretch that amplitude up, or we could shrink it down, but that amplitude, that space between the principal axis and the minimum or maximum, if we actually go back to this picture here, the amplitude we can see is 1 unit. So that's that amplitude is just 1 in this case. So what's going to happen is it's going to stretch this up or shrink it down. So we have to graph y equals 4 times sine of x. So that means that our amplitude is going to be 4 because I have 4 in front of my function. So that's going to stretch my maximum and minimum up as well. So my maximum was at 4. My new maximum, my maximum is at 1. Now my maximum is at 4. And my minimum will be at -4. The period will still be 2 pi. The principal axis will still be at 0. Now, you will have some special graph paper you can use. Otherwise, we would sketch something like this. So, right down the middle is when I'd have 0. I'm going to go up to 4 and down to -4. And then I'm going to go all the way out to 4 pi here. So I can do 2 full cycles because we know 1 cycle is at 2 pi. So we can put all those key parts on our graph. And then now, how do I get the rest of this? I'm counting by, I'm like adding pi over 2 each time. So if I add another pi over 2, I would have 5 pi over 2. And then I go to 3 pi. And then my last one is 7 pi over 2. Keep in mind that like 2 pi is the same as 4 pi over 2. And 3 pi is the same as 6 pi over 2. So I'm still counting by pi over 2's as I'm going up here. And then pi would be 2 pi over 2. So you're going to kind of find that pattern and use it a lot. Now, once again, since we know that that period is going from 0 to 2 pi, I'm just going to have that one rotation. So I always start at 0, 0, but then at pi over 2, instead of the maximum being at 1, it's going to be up to 4. Pi is at 0, but then 3 pi over 2 is going to come down to that -4. And then 2 pi, I'm back at 0. So here we go with 1 cycle here. Now we can repeat that process because remember, it's cyclical, it keeps happening. So 5 pi over 2 will be back at 4, 3 pi will be at 0, 7 pi over 2 is -4, and 4 pi back at 0. So we can show that that amplitude is 4. It got stretched up. So the next one is going to be that horizontal stretch we'll look at next. So remember, horizontal stretches are being multiplied inside the function. So you can see we've got y equals sine times sine of b times x. So because it's a horizontal stretch, it's going to either squish it in or stretch it out horizontally, like with the x-axis. This will affect our period. It's really important you write this down, that the period equals 2 pi over b. So you can figure out the period and then take different halves of it to get all those other key parts. So I used 4 again so you can see how that changes it. So it'll change the period. So our period is 2 pi over b. Well, b is 4. So I've got 2 pi divided by 4, which reduces to pi over 2. So the whole cycle happens between 0 and pi over 2. Now I'm going to draw pretty close to the same graph again, except for my altitude or my amplitude did not change. So I can just go from 1 to -1 and put the rest of these in here. You can see my smartboard is a little bit, it's hard for me to draw those lines, so they're a little bit crooked. Alright, so here's the deal. My period is so small here that I'm going to have to go up, down, and back up to 0 right in this one little section. So in the middle here, that's going to be pi over 4 because it's halfway in between. So I'll start. And then again, halfway in between that is when I'll be back up. So halfway in between, I'm at 0. Then halfway again, I'm down at -1. So I have this pattern. It's going to keep repeating. So that same pattern repeats at every little interval then. So I'm going to keep that going. Up, down, back up. Up, down, back up. Up, down, back up. Up, down, back up. Now yours will be a lot nicer because you won't have the smartboard kind of going crazy, but we should have that amplitude should just be 1. My amplitude is just 1 because I'm going from that principal axis, which is still at 0. So we change the period there. Okay. So write down the general form of a sine function and explain how a and b affect the function. So y equals a times sine of bx. So a is going to affect the maximum and minimum. It's going to affect the amplitude, either making it bigger or smaller, so a vertical change. And b will affect the period. It'll be that horizontal stretch. So just a couple of little questions. Given the period is 4 pi, so it's stretched out to 4 pi for just one cycle, what's b? So remember, the function was that the period is equal to 2 pi over b. So if I know the period is 4 pi equals 2 pi over b. So I'm going to multiply by b. So I've got b times 4 pi equals 2 pi. And then when I divide, b is equal to 2 pi divided by 4 pi. Well, these pi's cancel out. 2 over 4 will equal 1/2. So b would actually be 1/2 for this function. So it would be like sine of 1/2 x. And then our last little example here is, what if it's y equals negative sine x? Now, if I was in class with you guys, I would ask you to remember, like, what does that negative do? But it's a reflection, remember. And so what will happen is that my function, the period and the amplitude would all stay the same. So I'm still just going between 1 and -1. And again, I'm going to take mine out to 4 pi just for consistency. Your assignment will have like different lengths it wants you to do. And you'll get better at remembering these numbers as we go on. Oops, this one's 5. So the thing is that normally I would go up to 1, but I'm going to have to go down to -1 because it's reversed. So that reflection now goes the other direction. So it's still, again, having like the same period. It's still 2 pi. The amplitude is still 1. But, again, it's reflected because it has that negative. All right, so that's it. I'll be back tomorrow and we can go over any of this. You guys will be good.